Good morning and welcome, my intelligent students, to another great math lesson. We're going to be, it's like 5-2, but it's going to be called Graphing with Intercepts. So behind me is the definition of an intercept and a coordinate plane. So when I step out, I'm going to hit pause. I want to make sure that you copy this stuff down, and then I'll go over it. All right, hopefully you have this all copied down. So let's just quickly go over the definition of what an intercept is. All right, so first of all, it's just a point or an ordered pair, an X and a Y, where a line crosses over either the X-axis or the Y-axis. And that's all an intercept is, right? So let me just draw some quick lines for you. So let's just draw a line right here. All right? Intercept. 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 Intercept, intercept. So basically it's just that. It's just a dot that is on either the x-axis or the y-axis. So what I'm going to do is I'm actually going to place some letter values next to these. We'll call this A, B, we'll call this one C, we'll call this one D, and we'll call this last one E. So go ahead, hit pause right now. All right, so you've labeled the A, B, C, D, and E, and I'm going to hit pause again, and we're going to kind of look at the difference between an x-intercept and a y-intercept. All right, so I added a table for your notes, so why don't you go ahead, and I'm just going to step off right here, hit pause, and just copy down that table real quick. We're going to be adding a lot of stuff to it, so you'll have other opportunities. All right, so... All right, we're done. All right, so x-intercept. So I'm going to look at the dots that cross the x-axis, right? Here's the x-axis, and we're going to basically see if their numbers have anything in common. So let's look at point A, right? So I look at point A. I start at my origin. I go over 1, 2, 3. So on my x, I go over 3 spaces, but I don't go up or down. So my x value is, that's at 3, 0, because I don't go up or down. All right, so I go back to my origin. I go to B, 1, 2, 3, 4, 5, 6, 7. I'm already there. No up and down. Hopefully you guys start seeing the pattern. So this is at 7, 0. And then I'm just going to skip to C, 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9 on the X. Oops. 0. Right? And what you can mathematically see is, what do they all have in common? Is that on an x-intercept, because there's no up or down movement, the y value is going to be 0. So you will always have an x number, but the y will be 0. So y equals 0 on an x-intercept. Okay, so that's all an x-intercept is. But you do have to mathematically know that when you have a line that crosses over the x-axis, that the y number, because remember, there's always two numbers associated with the point. This is just not negative 9. It's negative 9, 0. So the y value equals a 0. And you're going to see why this is going to be so brilliant. All right, so now let's move on to our y-intercepts, and because you guys are so smart, you probably already know what I'm going to say, right? So let's look at D and E, which are on my y-axis. So here's D, and here's E. And so we go back to the origin, right here in the middle. And if I go to D, well, there's no sideway movement. There's no movement on the x-axis. So I just go 1, 2, 3, 4, 5, 6, 7, 8. So my y is 8. Because I didn't move anywhere side to side, that's 0. Now let's look at E, right? Any side to side movement? No. So the x is 0. And then you got to just go 1, 2, 3, negative 3. Right? So you figured that with the y-intercept, it's just the reverse. You have 0 for the x, and then you have some number for the letter y, or the x's equal 0. Okay? So this is the main concept, the main idea of graphing with intercepts. You're going to see how this is going to make actually graphing a line that much easier. You're going to love it because it's going to be less work than that horrible table graphing. So you'll see in a little bit. So make sure that you do have this table completed. So if you need to, hit pause right now. All right, and then we're going to go on to do some graphing. All right, so here is our first example. It reads negative 2x minus 7y equals a negative 14. So you can kind of pause it right now if you need to. Make sure you write down the equation, but then kind of write down this little table that I have set up. It says xint for x-intercept, and with a reminder that the y equals 0. And then with the y-intercept, the x equals 0. So make sure that you have this copied down. All right, so what do we do when we have intercepts, or when we graph with intercepts? Well, we get to do something really cool, right? And why it's so much better than table graphing. Table graphing, you have to use like 3 equations, or you got to use 5 equations, and it's just a lot more work. And as you can tell here, I only have to do this twice, right? So it's already cutting your work down. And this is how simple it is. So an intercept makes one of the coordinates 0. So in this case, on the x-intercept, the y becomes 0. Well, that's perfect, because what's negative 7 times 0? It's 0. So guess what I get to do? I literally get to cover up the negative 7. The whole y term disappears. So all I'm left with is this. Negative 2x equals negative 14. Because the y got canceled out with this multiplication of a 0. And look, we're left with an easy one-step equation. Divide both sides by negative 2. And then x becomes a positive 7. But remember, it's a point. It's an ordered pair. So your answer for the intercept is the x term is 7. But again, because it's an x-intercept, the y is 0. So we get to put 7, comma 0. There's one of our points. Now, we come over to the y-intercept, and it's just the opposite. So on the y-intercept, we want to basically get rid of the x, and we do with the 0. If you put the 0 where the x is, negative 2 times 0 is 0. So again, on the y-intercept, you keep the letter y, so we can just cover that up. And so what do I have? Negative 7y equals negative 14. Right? So, because the x term is eliminated by that 0. That's why it makes the intercept so special. So, again, I'm just going to divide by negative 7. Divide by negative 7. Some of you guys probably do this in your head now. And you have y equals a positive 2. But, again, your answer is an ordered pair. It's a point on a graph, and a point always has 2 numbers associated with it. So your x is what? 0. That's why it's called the y-intercept. And you have a y term. So there's your 2 points. And that's all we're going to use for this graph. Now, if you need to, hit pause again. Make yourself a new coordinate plane. So make a new coordinate plane, and then make sure that you have all this copied down. But make sure that you understand how we got to that, and then we're just going to quickly graph this. All right, so hopefully this is copied down and you have a new coordinate plane. So I'm going to take my 2 points, okay, my 2 intercepts, and I'm going to plot them. So I'm going to take my x-intercept, right? Now remember, my x-intercept is going to cross over the x-axis. So it's going to cross over at 7. So I'm going to go 1, 2, 3, 4, 5, 6. I need to make another mark, 7. So I'm going to put a dot right here. That's at 7. So that's 7, 0. And then I'm going to graph 0, 2. But remember, this is a y-intercept, so it's going to be on my y-axis. So I'm going to start at the origin. You don't go anywhere. You go up 2, put a dot. And that's how you kind of know your answer's right. Every answer on graphing intercepts will give you 2 dots, one on each axis. Now remember, draw a line all the way through them. You know, make that line go all the way through your graph. All right, so basically that's how you do x and y intercepts. Maybe I'll put one more example, and then we'll call it a quit. So make sure that you have everything. You should already have everything copied down. You can make the line. Okay, so we have a new example. So here's example 2. It just says x minus 2y equals -2. I have the same little table set up. Let me know what side's my x-intercept, which side is my y-intercept. I rewrote down the equation twice, but I am going to go faster because you guys are so intelligent on this. All right, and I'm going to switch over to the black marker because I left up my old line. All right, so again, when the y is 0, the y term disappears. You only keep the x. That includes, and here's the beautiful part, it takes away this negative. Because -2 times 0 is 0. We can call it the cover-up method. You can cover up the y term, and look, this is easier than the last one. Once you cover that up, all we have is x equals -2. You're done. So you put your point, x is -2, y is 0. Easy, right? Now we do this one. This time, with the y-intercept, you're going to keep the y, so I do have to keep this -2 because that's part of the y term, but I cover up the x, so the x is gone. So what do I have? -2y equals 2. Divide by -2, and y will make a -1. I'm not going to show that math because you guys are so smart, but again, that means x is 0, and that is 1. So if you need to, hit pause right now, copy down that work. It's pretty easy. Excuse me. And then I'm just going to turn around and we're going to graph this line. So my first point is at -2, 0. So -2, 0 is right here, 1, 2. And then my second point is 0, 1. So it's 0, now these are really close together. So just don't do this. Nope. All right? Draw the line all the way through. Okay? So that's your last problem. And as you probably saw right beneath me, here's your practice problem. This is you have to solve this and graph it before you get the worksheet. So it's 2x plus 5y equals 20. And while you're solving this, have a math-tastic day.